Welcome back to our General Chemistry 1. Today we will discuss Module 4, which is about classifying matter. Before we delve in, let us go to our objectives. At the end of this lesson, you can say that yes, I can describe the classification of matter in terms of composition, and yes, I can recognize some methods of separating mixtures into their component substances. Let's go back to our definition of chemistry. As I have stated before, we will always go back to the definition of chemistry in every lessons that we tackle. We define chemistry as a branch of science that deals with the study of number 1, properties of matter. Under this, we have studied the different phases of matter, the physical and chemical properties of matter, and the intensive and extensive properties of matter. Measurement will be discussed on a later date. The second one is the composition and structure of matter. Under this, we have your pure substance, which includes the element and compound, and mixture, which includes the homogeneous and heterogeneous mixtures. In order for us to better understand the classification of matter, we have this graph to help us. If matter were to be classified according to its composition, then matter could either be a pure substance or a mixture. Now, when we speak of pure substances, we are speaking of something that contains only one kind of matter. This can either be one element or one single compound, but every sample of this substance that you examine must contain exactly the same thing with a fixed, definite set of properties. Let us take water as an example. Now, water is always composed of two hydrogen atoms and one oxygen atom. The property of water is the same all throughout. As an example, it boils at 100 degrees Celsius, it freezes at 0 degrees Celsius. It will always be composed of two hydrogen atoms and one oxygen atom. It will always have the same taste, so that means pure substances is only composed of one type of particle. The type of particle that composes these pure substances could either be elements or compounds. Now, when we speak of elements, these are the simplest pure substances. An example of these are oxygen, hydrogen, sodium, carbon, iron, and lead. Now, the smallest particle of an element that has the properties of that element is called an atom. So that means the basic unit of elements is the atom, and that these atoms are the ones that undergo chemical reactions. What about compounds? Compounds are pure substances that are made of more than one element bound together, such as your water and then carbon dioxide. The smallest unit of a compound is called a molecule. Molecules are formed when two or more atoms chemically combine. Compounds are substances which are composed of two or more elements, such as your table salt. Now, table salt is composed of two different elements, which are your sodium and chlorine. So long as these substances are combined chemically or are joined by a chemical bond, then that means it is under compounds. Another is your table sugar. Table sugar is always composed of 12 carbon atoms, 22 hydrogen atoms, and 11 oxygen atoms. Under elements, we have four classifications. These are your metals, nonmetals, metalloids, and noble gases. Under your metal, elements are good conductor of heat and electricity and have the tendency to form positive ions in ionic compounds. Other characteristics of metal includes ductility or the ability of a metal to be drawn into thin wires, malleability or the ability of a metal to be hammered into thin sheets. Also, metal exhibits metallic luster when polished. These are the different metals that can be found in the periodic table of elements. As you can see, most of them can be found on the left side of the periodic table and on the bottom portion. Next are your nonmetals. When we speak of nonmetals, these are the elements that are usually poor conductors of heat and electricity. Some other characteristics of nonmetals include brittleness or are very fragile or are easily broken. They are either very shiny, such as your precious stones, or not shiny at all, such as your oxygen or your chlorine gas. Nonmetals are generally located on the right side of the periodic table, with the exception of hydrogen. Next are your metalloids. Now, metalloids are a cross between metal and nonmetals. That is because they exhibit both the characteristics of a metal and a nonmetal. Metalloids, on the other hand, exhibit properties intermediate between those of metals and nonmetals. We have your iron as an example of a metal. No metals are good conductors of heat and electricity. Oxygen, an example of a nonmetal, is a poor conductor of heat and electricity. Silicon, number 14 in your periodic table of elements, is an example of a metalloid. It is an element that does conduct electricity and heat. However, it is not as good as your metals. Therefore, metalloids are semiconductors, meaning they allow electricity and heat to flow through them. However, it is not as efficient as your metals. These are where your metalloids are located. They form the ladder in your periodic table of elements. It includes only 7 elements, these being boron, silicon, germanium, astatine, antimony, tellurium, and polonium. Lastly, under the elements, we have your noble gases. Noble gases are elements that do not undergo chemical reactions in nature. This is because noble gases are stable on their own, meaning they do not have to undergo chemical reaction in order for them to attain stability. The noble gases can be found on the rightmost part of the periodic table of elements. They are your helium, neon, argon, krypton, xenon, radon, and oganesson. We have to clear up the confusion in the use of the term noble gases from inert gases. Now, when we speak of noble gases, they are composed of only one element. These are elements that are already stable on their own, whereas inert gases could be compounds that have a chain stability. So, noble gases are composed of only one element, whereas inert gases are composed of two or more elements which have achieved stability through chemical reaction. And that's it for our elements. Let us now go to our compounds. Alright, let's go to our compounds. When two or more elements chemically combine in a fixed ratio by mass, the obtained product is known as a compound. Compounds can be defined as substances consisting of two or more different elements in a fixed ratio of its atoms. Before we proceed, let us define chemical bonds. Now, chemical bonds are present when two or more elements undergo a chemical reaction. A chemical reaction is a rearrangement of atoms. Now, since the atoms are rearranged, their chemical properties will also be altered. An example of this is sodium. Now, sodium is a metal that reacts violently with water. When ingested, sodium can be poisonous. Another element is chlorine. Chlorine is a greenish yellow gas that, once inhaled, could be toxic. It is also used to disinfect and kill bacteria. Now, when these two chemically combine, they form a substance that is essential to life. They produce a substance that you make use of as a condiment. It is known as sodium chloride. Now, because of the bonds that exist between the sodium atom and the chlorine atom, it is now classified under your compounds. Compounds can be classified as an acid, a base, a salt, or an oxide. Some properties of acids include the yielding of hydrogen ions when dissolved in water. Other characteristics of acid include sourness, turning blue litmus paper to red when dipped in the solution, and that their pH level is lesser than 7. Also, another characteristic of acids is that they have hydrogen at the beginning of their chemical formula. An example of this is HCl or hydrochloric acid. Next, we have your bases. When we speak of bases, they are substances that yield hydroxide ions when dissolved in water. Other notable characteristics include turning red litmus paper to blue, being bitter, slippery to touch, and that they include OH at the end of their chemical formula. Examples include NaOH or sodium hydroxide, LiOH or lithium hydroxide. Now these are the different formulas for common acids and bases. Using the formula, we can determine if the substance is an acid or a base. As I have said earlier, acids generally have H at the beginning of their chemical formula, such as these ones. We have hydrofluoric, hydrochloric, hydrobromic, hydroiodic, and hydrosulfuric. Bases generally have OH at the end of their chemical formula. These include sodium hydroxide, potassium hydroxide, and whatnot. Next, we have your salt. Salt is a combination of one positive ion and one negative ion. Salts are usually produced by the reaction of acids and bases. We call that neutralization reaction. In neutralization reaction, or the reaction between acids and bases, salt and water are usually produced. Lastly, we have your oxides. When you speak of oxides, these are substances which are composed of two elements, with the other one being oxygen. An example of this is carbon dioxide. Carbon dioxide is composed of one carbon atom and two oxygen atoms. Another is water. It is composed of two hydrogen atoms and one oxygen atom. So that means any substance being composed of only two elements and that the other one being oxygen, it can be classified under your oxides. Now, since we are already in the compounds, compounds are generally divided into two. They could be organic or inorganic. When we speak of organic compounds, these are compounds that contain carbon and hydrogen, with some addition of elements such as oxygen, nitrogen, sulfur, and phosphorus. For organic compounds, we have your methane, which is composed of one carbon and four hydrogen atoms. Another example for organic compound is acetic acid or the vinegar. It is composed of two carbon atoms, three hydrogen atoms, and two oxygen atoms. Whereas inorganic compounds are compounds that do not include carbon, hydrogen atoms. For inorganic compound, we have your NaCl or sodium chloride. We have carbon dioxide or CO2. That concludes our discussion for your pure substances.